Unit 3 Review, Question 39. Solve the following division problem using remainders. Write your results symbolically as both multiplication and division equations. So we have 58 divided by 7. So let's start by writing this as a long division problem. And now let's look at the calculator. So how many times does 7 go into 58? What's the most amount of times? And the whole number part, 8, that's the most it goes in. And this, even though it's what's left over, this is written as a decimal or a decimal fraction. Okay, so this, we don't call this the remainder. So first let's just deal with the 8, and then we'll see what the remainder is. So it went in 8 whole times. 8 times 7 is 56. We have 2 left over. 7 can't go into 2 anymore, so that's our remainder. So our remainder is a whole number. Okay. So to write this as a division equation, we'd say 58 divided by 7 equals, we'll write 8 with a remainder of 2. Now, what does this mean in terms of a multiplication equation? Well, let's see what we did here. We found that 7 times 8 was 56. And then our result was 2. So if we add on the 2 to the 56, that gets us back to our original dividend, 58. So this is our corresponding multiplication equation. So 7 times 8 plus 2 equals 58. Let's look at the next one. Solve the following application problems using division with remainders. Make sure to include units in your answers. So we have, Sean is biking at a rate of 14 miles an hour. He wants to bike a total of 71 miles. So first we're asked, what is the maximum number of whole hours he will spend biking? So if he wants to go, let's look at our distance equals rate times time. Okay. We also saw that we can rewrite this. We're looking for hours, which would be time. So equivalently with division, time equals distance divided by rate. So our distance is 71 miles and our rate is 14 miles an hour. So this is rate. This is distance. So we want to divide 71 by 14. So let's see what this looks like. Well, what's the most amount of times 14 goes into 71 without going over? Well, that would be 5, and then there's some left over. This is the decimal fraction, not the remainder. So let's start with a 5. Now we'd multiply 4 times 15 and subtract. Or did I say 4? 14 times 5, sorry. And 14 times 5 is 70. And we have a remainder of 1. Okay. So what does this mean in the context of the problem? Well, that means that when we divide 71 by 14, we have 5 full hours, and this 1, what is this 1 representing? Well, it could be 1/14 of an hour, okay, but we're not dealing with fractions yet, so the 1 left over was from the 71, and that was miles. So he would have 5 full hours to go 70 miles. So that's what this was, and then there'd be 1 mile left over. Okay. So now let's look at these questions to see how we will answer them. So what is the maximum number of whole hours he will spend biking? So that will be 5 full hours. It wouldn't take him 6 full hours at the speed because it's between 5 and 6. So 5 full hours. How many miles will he have left to travel after riding this maximum number of whole hours? Well, we saw that remainder of 1, that was the number of miles he has left over. So we will have 1 mile left to travel. Let's look at the next one. Find all factors of the given numbers by finding factor pairs. Write your final answer as a list of factors separated by commas. So we have 24, and our process for this is we start with 1 times 24. So the number itself and 1 are always factors of the numbers. Then we're going to increase 1 to 2 and see if 24 is divisible by 2. And it is. 24 is 2 times 12. Move up to 3. 24 divided by 3 is 8. Okay, so these are factors. Move up to 4. 24 divided by 4 is 6. So these are factors. Move up to 5. Well, 24 isn't divisible by 5. Let's take a look at it. So since there's a decimal, that means there's a remainder. I'm going to write this 4.8 though. And then we'll cross this out. Okay. So these are not factors, but notice here the left-hand numbers were smaller than these numbers. When the left-hand number is larger than the right-hand number, that means you can stop and that you've checked all of the possible factors. So now I know all of these numbers are factors of 24 and they're the only factors of 24. So I can write my list. I start on the left. Let's write them in order. So 1, 2, 3, 4, and then circle around, and then you'll keep them in increasing order. 6, 8, 12, and 24. Now let's look at 180. So we're going to start with 1 times 180, starting a little bit higher to make sure we have enough room. Does 2 go in? Yes, it's 2 times 90. And again, you could check these on your calculator by dividing 180 by 2. Let's do that for the next one. Does 3 go in? And you divide 180 by 3. And if it's a whole number, which it is, it goes in and it's a factor. So this would be 60. Let's try 4. Is 180 divisible by 4? And yes, it is. It's 4 times 45. It's going to be divisible by 5 because it ends in 0. So let's try that. We get 36. Is it divisible by 6? So these have a lot of factors. 180 divided by 6 is 30. Okay. Notice I'm going to keep going. These numbers are still a lot smaller than these numbers. Let's try 7. Is 180 divisible by 7? And it's not a whole number, so that means no. So I'm going to cross it out. Let's try 8. 180 divided by 8. There's a decimal, so no. Let's try 9. So 180 divided by 9 is 20, so those are factors. Let's go up here. 10. 180 divided by 10 is 18. You can check that on your calculator. Okay, this number is still smaller, so we have to keep going. Let's try 11. 180 divided by 11. No, and we have 16, so we're going to keep going. Let's try 12. 180 divided by 12 is 15. So those are factors. Notice the numbers are getting very close, so I'm almost done checking, but I have to keep going. 180 divided by 13. 13.84. And I'm going to write that about 13.84. That's an about and approximately. Okay, so this is not checking. And I actually know the next one, since these are both around 13, the next one is going to be 14 is going to be smaller than the other factor. But let's just verify that. 180 divided by 14, and then we get 12.8 blah blah blah. So that's not a factor. And since the number on the left is bigger than the number on the right, I know I've checked as far as I need to check, and I can write my list. So a lot of factors. 1, 2, 3, 4, 5, 6, 9. So I'm going down here. 10, 12, 15, 18. Let's start on the next line. 15, 18. Now reverse. 20, 30, 36. 45, 60, 90, and 180. Okay, so notice this is a long process, but it's important. I didn't happen to know off the top of my head that 180 was divisible by 36 or that 36 was a factor. So you need to go through this process to make sure you don't miss any.